Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today's topic is one that we at Horner would say is long overdue. Here's the topic: pairing Micro OCS with OCS-I. And the reason we'd say this is long overdue is because we had hoped to have firmware and software available for the Micro OCS to allow it to work with OCS-I a couple months ago. But as development projects often go, sometimes they take longer than expected. Sometimes other projects and priorities get in the way. But either case, as we stand today, we've just released the software and firmware required so that the Micro OCS can be used with our new remote and local I/O system, OCS-I. All right. Now, normally we would have our product manager, Casey Gardner, joining us today, but we had a few technical difficulties today, as we sometimes do when we're dealing with live streams. So it's just going to be me today. All right, let's take a look at how we're going to break down today's topic. Okay, we're going to do a quick review of the Micro OCS family and of OCS-I, just one slide each. So we're not going to look too far backwards. We're going to talk about some of the use cases and the applications where you might decide to use the Micro OCS with the OCS-I. We're going to talk about the Seascape and firmware requirements for the two products to be able to work together, and we're going to demonstrate how to do Micro OCS firmware upgrades. So if you've already got Micro OCS controllers in your possession and you need to do an upgrade, that you'll know exactly what to do. And we're going to have plenty of demonstrations throughout. Let's go ahead and get started. Here's our one-slide review of the Micro OCS. At Horner, we like to think of the Micro OCS as the best all-in-one controller for simple applications. No, it's not as fast or with as much capacity as some of our other product lines, but it has plenty of speed and capacity for a lot of different applications. It's available in 4 different screen sizes, starting with a 2-inch monochrome that includes the keypad. And then there's 3 models that have color touchscreens, a 4-inch, 7-inch, and 10-inch model. Now, depending on which of the 2 I/O options you choose, you can get either 26 or 30 built-in I/O points, the difference being whether you prefer relay outputs. In that scenario, you'll get 26 total I/O, or solid-state outputs. In that scenario, you'll get 30 total I/O. Now, all models come built in with RS-232, RS-485, and CAN as standard. Now, the 4, 7, and 10-inch models have Ethernet standard as well. So that's the Micro OCS, just a terrific entry-level product from Horner. Now let's take a look at the OCS-I family. Now, this is our latest plug-and-play IP20 I/O system in all Horner design. The OCS-I allows you to add I/O where you need it. It can be inside the same control panel where you've mounted your OCS, or it could be distributed up to 500 meters away. Now, even though it looks like you're connecting over Ethernet because of the cabling, you're actually using RJ45 to connect C-SCAN. And C-SCAN is Horner's plug-and-play network for adding I/O to any OCS system. Now, with OCS-I, you can have up to 8 I/O bases per system, and with each base, you can have a total of up to 8 modules, including the base itself. And there's a wide variety of modules available. Now, one of the things we like to highlight with OCS-I is the CNX116 base. It not only provides the connectivity to the OCS, but it includes 6 I/O points of its own. 2 of those 6 I/O points are called flexible inputs. They can either be digital or analog I/O. 2 of the I/O points are solid-state DC outputs up to 2 amps each, pretty beefy. You've got 1 high-resolution universal analog input, thermocouple RTD, 0 to 10 volts, 4 to 20 milliamps with 16-bit resolution, and you've got an analog output point where you can choose between voltage and current. So that just goes to show you that even if all you add is the base module, you get some really useful I/O when you add OCS-I to your system. So enough review. Let's talk about some use cases between the 2 product lines. So let's say you've got an application or a machine where the Micro OCS really has everything you need to control your machine, but you're really lacking a high resolution temperature reading so you can do some really high-end temperature control. So in that scenario, you might want to add one or more thermocouple or full-range RTD sensors to your system, and by adding OCS-I, that's one way you can really accomplish that. Here's another scenario. Maybe you need to support a number of high current relay outputs in your system, and there's either not enough current capacity or not enough relay outputs built into the relay option for Micro OCS, so adding additional relay support is another use for adding OCS-I. Here's another scenario. Let's say you've got a retrofit application, in other words, an existing machine with existing machine controls, and you want to modernize the controls. Now, most of the time when that happens, you strip out a lot of the sensors and things, and you switch everything from AC to DC. Now, that doesn't always happen, though. Sometimes it makes a lot of sense to leave some AC signals there, but in that scenario, you need to interface with them, and the OCS-I supports an 8-channel AC input module. So for adding a number of AC input signals to your system in a retrofit, that's another scenario where it just makes sense to add OCS-I to the system. So those are just 3 use cases. There's literally dozens, but we thought we'd review those with you. Now let's talk in detail about the requirements to add OCS-I to the Micro. First of all, software and firmware, and that's what we've released today as we air this video. So we've just released CScape 9.9 Service Pack 9, and Micro OCS firmware 15.7. So that's the basic requirements. Now let's take a little bit deeper look at the firmware requirements for the Micro OCS. So yes, firmware needs to be at 15.7, but the CPLD and the BIOS also should be at the latest levels. And on those 3 tables to the right, we're showing what those labels are by model. So you're going to want to figure out whether, for your case, is it only firmware that needs to be updated, or do you need to update BIOS and CPLD as well? Because the update procedure is a little bit different, but don't worry, we're going to demonstrate both for you. From a hardware component standpoint, you're of course going to need the Micro OCS model. You're going to need at least the OCS-I base, and if you need additional modules, you'll need those as well. And then you'll need an RJ45 patch cable and a terminator plug. And one other note, if you're going to be doing the firmware update, you are going to need a USB cable that is USB-A to USB Mini B. Now let's talk about the procedure for performing the upgrade on the Micro OCS. So you're going to need to download and install CScape 9.9 Service Pack 9 or later. You're going to want to download the firmware packages for 15.7 or later for each of the different Micro OCS models that you're needing to upgrade, X4, X7, X10. Now, once you've downloaded those firmware packages, you're going to want to install all those files in the firmware folder under CScape. So wherever you've installed CScape, there will be within that folder a firmware folder, and that's where those files need to go. And then you're going to need to take that USB-A to Mini B cable I just talked about and connect your computer to the Micro OCS and establish a connection. Next, we need to figure out, is it only a firmware upgrade that we need, or do we need to upgrade the BIOS and the CPLD as well? Well, how can we determine that? Well, first of all, a couple slides ago, of course, we had a series of tables that showed you the required versions, and you can freeze frame this video later and go back and check those out. But the way to find out what you've currently got, there's 2 ways to do it. First, if you have your controller online with CScape, you can go to the controller menu under status, and then right there where we've highlighted it in red, it will show you firmware, BIOS, and CPLD. Or if you'd prefer, and the unit is at your desk, for instance, and powered up, you can go to the OCS's system menu and go to the status area and scroll down until you see, again, firmware, BIOS, and CPLD. And based on those version numbers, along with the tables a couple slides ago, you can determine, is it only firmware I need, or do I need to upgrade all 3? Let's look at the scenario first where all we need to do is upgrade the firmware. That means the CPLD and the BIOS are already up to speed. So again, make sure we've connected CScape 9.9 Service Pack 9 or later to the Micro OCS over that USB-A to Mini B cable, and we've got our connection established. That's the prerequisite, if you will. And next you're going to go to the File menu in CScape and select the Firmware Update Wizard. And what you'll see when that pops up is that if you were online with your controller, Cscape was automatically able to determine which of the Micro OCS models that it's connected to, and it's ready to go because all you need to do is update the firmware. You can press the OK button, and everything will get upgraded in a single step. Now, one little note here. Anytime you upgrade firmware with any of your OCS controllers, the application program will be deleted. So if you haven't saved your application program, make sure you do that first. So that's really all that's required if all you need to do is upgrade the firmware. Let's go ahead and demonstrate this relatively simple case so you can see how it's done. Let's go ahead and perform a firmware only update. So this particular X7 or Micro OCS that I'm updating only needs to have the firmware updated. So I'm going to go to File, Firmware Update Wizard. I'm going to go ahead and notice that Cscape automatically selected X7. And I'm going to go ahead and just press OK. All right. Now, if we take a look at what's happening on the OCS side of things, we can see that the system firmware loader has popped up on the screen if everything's going as we expect. I'm going to press the Start button. So we're starting the download process, and we should see the progress bar changing soon, and we do. Again, if we take a look at what's happening on the OCS side of things, we can see that little indicator at the bottom there rotating. All right, so we're processing through the firmware update. It says download is complete. So we press close and OK when it's ready. Update complete. Now let's take a look at what things look like on the OCS side of things. Well, what's happening is the OCS is in the middle of a reboot. We're getting failure messages, but that's normal because it's got new firmware, which means it has no application program, no hardware configuration. So therefore, it sees that as an error. So this unit is ready now to be programmed with our application since it has the new firmware. Okay, so that was the process if all you need to do is upgrade your firmware. Now let's take a look at the case where not only your firmware, but also your BIOS and CPLD require updating. So it starts out exactly the same way. Cscape 9.9 with the firmware file set in the right folder, connected to the OCS online with the USB-A to Mini-B cable. And we do go to the firmware update wizard from the Cscape file menu, but this time, instead of just leaving it at its default, we click on the manual checkbox, and we make sure from that pull-down menu that we select boot/CPLD for the update. Then when we press OK, Cscape is going to prompt us to take an extra step, and that is, it's going to prompt us to press a recessed load button on the back of the Micro OCS to kick off the update to the bootloader and the CPLD. Now, instead of kind of talking about these steps, let me go ahead and demonstrate them for you with another video. Okay, now this time we're going to update an X7, which does need to have not only firmware, but also its BIOS and CPLD updated. Now it starts out in a similar way. We still connect up the OCS over USB. We go to File, Firmware Update Wizard. But since we need to update everything, we're going to have to press Manual and make sure that boot/CPLD is selected. Then when we press OK and press Start, we get some special instructions. So basically it's telling us that we have to press the load button, the physical load button on the back of the unit, and apply power for that to start. Okay, so let's go ahead and go to our benchtop view here. And I'm going to show you that up here in the corner, okay, by the USB port, there's a little hole where you can access that switch. Now, you could use a paper clip. I'm happening to use just a piece of wire, all right, to actually act as my push button. So I'm pressing down to push that load button. Now I'm going to power the unit off and power the unit back on again while holding the button down. Now I'm going to let go. All right, let's go back to our Cscape view, and it's telling us what to do next. Basically, it's saying press OK below. All right, let's do that. And then press the Start button. Okay, and see what happens. Okay, it appears to be working. We've got progress going on here. I'm going to flip that unit over again. So let's see what happens if we're making the progress we need. It says firmware download successful. Reboot the device. I'll go ahead and power it down and power it up again to reboot it. I'll hit the close button. Okay. Let's take a look at the unit now and see what it's telling us. There we go. So it's telling us that it's loaded the part that it needed to load, right? The CPLD is done, it says. So let's go ahead and restart the unit as it's asking us to. All right, let's go back to Cscape. Hit OK. All right, now let's go back to the benchtop and take a look at what the message we're getting here. Okay, that message says app CRC fault at the bottom. That's what that says, fault app CRC. Why is that? Well, it's because it doesn't have the regular firmware loaded in it. Okay, so now we need to go ahead and load the firmware. So let's go back to Cscape, go back to File, Firmware Update Wizard. Now this time it doesn't know that we've got an X7 connected because it's not, it doesn't have the standard firmware in it. So I'm going to scroll down to find X7. I'm going to click Manual and Primary Firmware and hit OK. Then I'm going to hit Start and let's see how it does. Okay, let's see if we get some progress happening here. We do. Let's go back and take a look at the bench. We can see it does appear to be loading as we want. All right, so let's see what happens when this completes. Okay, download complete. Let's go take a look at what we're seeing on the OCS display. And what we're seeing is the unit's rebooting, as we would expect. And just like before, when we did just a regular firmware update, eventually we should see errors because there's no application program running in it. But that's normal again, because without configuration, without an application program, we're going to get some errors. So this unit, which did require an update to not only firmware, but also the CPLD and the BIOS, this unit now is also ready to be programmed. So as you can see, if you need to update more than just the firmware, there are extra steps involved, but hopefully with the aid of that video, you can have the comfort to go through that process yourself. So regardless of which approach you had to take to upgrade your Micro OCS to 15.7, you are now ready to connect OCS-I/O, configure everything, and get it all running. So what's that process look like? Well, we start by assembling and powering up the OCS-I/O. Maybe it's one module, just the base. Maybe it's a base plus several modules, whatever the case may be. So get that physically assembled and powered up. Now you want to connect an RJ45 patch cable between your Micro OCS and the in port on the network side of things for the OCS-I/O. Now, next you need to make sure things are properly terminated. So on the OCS-I/O side, that means utilizing the terminator plug that's available as an accessory from Horner, and you place that terminator plug in the network out port on OCS-I/O. Now, on the OCS side of things, you don't have a place to put in a terminator plug. That termination is done in software from the system menu. So you go into the system menu, you go to the network area, to the CAN area and you enable termination on the OCS CAN port. And now you're properly terminated on both sides. Now, is termination necessary? I say for best practices, absolutely yes. Make sure your system is properly terminated. That way you know you're going to have trouble-free operation for the life of the equipment. So that's the kind of step one of getting everything powered up and connected. Next, it's time to do the configuration, and that can all be done from Cscape. So we go through the configuration process, we download our application program. Once we've done the configuration, we place the Micro OCS into run mode, and the last step, which would probably be required in most cases, is a power cycle of both components, and then when they come back up again, they'll be up and running as normal, and you'll be completely done. Okay, let's go ahead and take a look at configuration and all the way to run mode with OCS-IO and the Micro OCS. Now that we've got our firmware updated, our Micro OCS should be ready to accept OCS-IO. All right, let's take a quick look at our benchtop, and you can see I've got my X7 that's had its firmware updated to the appropriate level, and I've got a couple of OCS-IO modules there. I've got the base plus one module to the CNX116 plus one ADU module that has 4 additional high-resolution universal analog inputs. Let's go ahead and get everything set up and going. So back to Cscape. I'm going to create a new application in this case. I haven't started my application yet. I'll make it based around variable based advanced ladder. I could use any of these languages. It doesn't have to be variable based. So my new program is opened and blank. I've got my variable window where I want it now, and let's go ahead and do some configuration. All right, well, the first thing we better do is communicate with our controller. So let's go to controller. Now, in my case, I went ahead and I normally program over Ethernet. So that's what I'm going to do here, is program over Ethernet. So I got to set my IP address to the appropriate address, hit finish, and then I should soon be talking. There we go. So I'm talking and I'm in idle mode because, again, I just updated the firmware in the controller and it doesn't have a program in it. So here we go. Let's go to the hardware configuration. This is our controller that we're dealing with. Let's go to CAN1IO, hit add. Let's find the OCS-IO base. We'll pick that CNX116. And I'm going to hit the Auto Populate All button. It's asking if I want to auto populate. I do. Now it's going out and searching, and it's saying, hey, we found a network ID available. And it is displaying the UUID. Click yes to assign this network ID to its respective base. The answer is yes. Auto populate is complete. All right, it's telling us we've successfully added this UUID to our system, which is the UUID of the CNX base. So we're good. We can hit OK. Now we can see not only the CNX116 that we just added, but the ADU100 that was auto-populated along with it. So let's go ahead and configure everything completely now. I double-clicked on the base. I'm going to give it a name. I'm going to call it whatever I want, but I'm going to call it OCS-IO. Network ID of 1 is fine. That's the CAN ID. We need a status register. This is variable based advanced ladder, so I'm going to assign a integer-based variable array that's 15 wide. I'm going to do it on the fly. So let's call this OCS-IO status. I'll hit the right arrow button here, hit the check mark. Unsigned integer is fine. I want a dimension of 15. And since it is a variable array, I need to reference the first element in the array, which is array element 0. Digital inputs. Now remember, we have built-in I/O in the Micro OCS. So I'm going to start my I/O, real-world I/O registers, if you will. I'm going to skip the first, let's skip the first 32 of each type. So I'm effectively starting at %I33, but in variable based, %I33 is the same as I32. I'm going to use that same offset for all my different types. I don't have to do that, but I'm going to do that just because I know I won't have any conflicts and it's easy to remember. And I'm good to go there. And then I can go and complete the configuration process. So if I want to go back into the CNX and go to the onboard I/O and change the configuration here, I can do that. Maybe I'm going to use the universal analog in. Maybe I'm going to use that for a J-type thermocouple in degrees C with a little bit of filtering to assist in the stability of the signal. I'm going to, for my digital analog or flexible inputs, let's go ahead and just make those digital 24 volt inputs. And then for my analog output, I'm going to make that a 0 to 10 volt analog output with 0 to 32,000 scaling. And when it halts, or in other words, when it's not under control by the OCS, I want it to go to its minimum value, or 0 volts in this case. And I'm not going to mess with changing the state of the outputs other than off when the controller is not available to control the I/O. Okay, so I'm saying okay here. And then under the ADU, if I double click that, I can go in and configure this as well. I'll give it a little bit of filtering to make the readings a little more stable. And let's say that we've got 4 to 20 milliamps on the first two channels. Well, let's say we have 0 to 10 volts on the third channel. And let's say we have a full range PT100 input on the last channel. And I'm going to go ahead and change the scaling to its maximum so I can take advantage of the full resolution. And instead of updating these every half a second or 500 milliseconds, I want to update them, let's say, every 50 milliseconds. That's a little more responsive. I could go faster if I wanted, but that's appropriate, let's say, in my application. So let's say okay and okay. So we've just completed configuration of the OCS-I/O with the Micro OCS. Let's put a nice little bow on our demonstration here and go ahead and download our program that we just configured in the last quick demo. It's warning us because I am now programming over Ethernet. It's warning me to make sure my IP address is set the way I want. Otherwise, the download could fail at the very end as soon as it sets the IP address to something I don't want. So we will do this initial download. Now, the initial downloads always take longer because, after a firmware update at least, because when you're doing a smart load, you pretty much have to set everything because nothing is set in that initial download. Then subsequently, when you're just changing logic or screens or some combination, the downloads typically get a little bit shorter. So once this is complete, we've got to remember to go into run mode, which I will do now. Now we are in run mode. Let's take a look at the bench and see what we've got. And sure enough, we have all greens, all solid lights on OCS-I/O, and we are getting values on the screen. Now, if this was the initial download and I was not getting all solid lights on the OCS-I/O, then I would simply need to do a power cycle one time, and then everything would come up and run as you see here. So at worst case, you do a download and then a power cycle, and you're up and running. So we are getting values as we expect, and our demo is now complete. So that should be everything you need to know in order to take your existing Micro OCS products and allow them to support OCS-I/O. So let's do a wrap up. So we have now released the necessary software and firmware versions to allow these two product families to talk to each other. And they do work really well together. Micro OCS is a really functional entry-level controller, and OCS-I/O is terrific at filling in all the gaps that might be missing from the Micro OCS for your application. And configuring the I/O is done from Cscape, and because Cscape can auto-populate the OCS-I/O, configuration is a piece of cake. So this is where I remind you that we're here every Tuesday at 2 o'clock whether we're fully live, whether we are presenting the material live like we did today with some pre-recorded demonstrations, or whether everything's pre-recorded because of a schedule. But in any case, we always have somebody standing by as we stream our videos live on Tuesdays, so you can get your questions in the chat section. And if you're watching on replay, you can always give us your comments and questions in the comment section. Now we're celebrating our 10th year of Horner Lighting Group products. There are plenty of great Horner Lighting Group videos on our APG YouTube channel alongside our automation content. This is really the start of trade show season. So next month, we're going to be at Automate in Detroit. And just like last year, we're going to be previewing some new products out into the wild for the first time ever. So you won't want to miss that. Now, speaking of trade shows, last week I was in Florida at the GCC Innovation Conference. Now, GCC is one of our great distribution partners in Florida, and they had a terrific conference held in Orlando, and I had the opportunity to show Horner products to a wide variety of existing customers as well as new customers, and also even give a presentation explaining why an all-in-one controller is an interesting alternative to a traditional PLC plus HMI. So as the trade shows occur this spring and this summer and this fall, when we come to your region, don't hesitate to come our way and check us out. For the May events, we've got 5 of them scheduled for you because there's 5 Tuesdays in May. Check out our newsletter with the announcements of each of the topics. Now, I will tell you, for those of you who stuck around to the end, we have a surprise new product that we're getting ready to introduce, and we're going to have at least one topic in May covering that new surprise product, and you won't want to miss it. If you haven't done so already, please subscribe to our channel. It doesn't cost anything, and if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do us some good.